Hi and welcome. Today we're going to be talking about the midpoint rule, which should be a little bit of a review from Calculus 1. The midpoint rule is written up here. It's delta x times f of x1 bar plus f of x2 bar all the way to f of xn bar. The delta x is just the width of the rectangles, which is given by b minus a over n, and x sub I is the average, so this needs to be divided by 2, of the previous endpoint and the next endpoint. Okay. One new piece of information about the midpoint rule that you have not seen before is this error bound. It tells you how good your approximation for the area is, and it's given by k times b minus a cubed divided by 24n squared. And k is any bound for the second derivative. So that's often a confusing point because there can be many values of k. And certainly there is a best value of k that's not required. Okay. So let's use this midpoint rule to approximate this integral from 0 to 1 of 13 times cosine of x squared. The first thing we're going to do is we're going to do delta x. That's going to be 1 minus 0 divided by 4. So delta x is 1/4. Great. There's going to be 5 values here that we need to calculate. Okay. And I'm going to just calculate x sub 1. Okay. Let's do x sub 1 bar. That's going to be the average of x sub 1 plus x sub 2. Okay. X sub 1 is just going to be 0. It's going to be a plus 1/4 divided by 2. So that's going to be 1/8. X sub 2 bar is going to be the average of x sub 2 plus x sub 3 divided by 2. Well, that's going to be 1/4, the value of x sub 2, plus 2/4 divided by 2. I should perhaps just write out that x sub I is a plus I times delta x. Okay, so that's how we calculate x sub I. And I believe to make my formula work, I should do an I minus 1 times it. Okay, yeah. Okay, this will give me 3/4, and then divided by 2 will give me 3/8. Great. The next one is x sub 3 bar. That's going to be x sub 3 plus x sub 4 divided by 2. Okay, so I'm going to have 2/4. When we calculate x sub 4, this will be 3/4 divided by 2. So this will be 5/8. Then finally we have x sub 4 bar. This will be x sub 5 plus x sub 4 divided by 2. So this will be 1 plus 3/4 divided by 2, and that will be 7/8. We're now ready to apply this formula for the midpoint rule. And this just says 13 times this integral of cosine of x squared dx. Well, we write down the midpoint rule, which is above. That's delta x, so 1/4 times by f of x1 bar plus f of x2 bar plus f of x3 bar plus f of x 4 bar. Okay, and then we just need to plug this in, and that'll be 1/4 times f of x 1 bar will be 13 times this cosine of x1 bar. x1 bar is 1/8. Then it needs to be squared, plus 13 times this cosine of x2 bar. That'll be 3a squared, plus 13 times this cosine of 5a. We'll square everything there. Then 13 times this cosine of 7a. We'll square everything there. So, depends if you prefer to write it like that or square numerator and denominator. Okay, and that will be what we need to calculate in our calculator. When we do that, we're going to get 11.81. Okay, so that is our answer for the midpoint rule, is 11.81. I think it might be nice to know the error bound for this. Okay, so if we go and ask for the error bound, so our question could be, how accurate is this answer? And it says the error from the midpoint rule is less than or equal to k times b minus a, that's 1 minus 0. That gets cubed, and I divide by 24 times n squared. Okay, yeah. Okay, so k, all that works out to be 1, and I'm going to have 24 times 4 squared. Now, we need to figure out the value of k before we proceed. So we know that f double prime of x, the second derivative, is less than or equal to this value of k. Any value of k that satisfies this inequality is going to be sufficient. We know f of x, that's 13 times this cosine of x squared. So let's start calculating derivatives using the chain rule. That'll be 13 times sine, and there's a negative here, so I'll put the negative there, times by the derivative of the inside, that's 2x. So minus 26 times by x times by sine of x squared. Okay. So that's the first derivative. Let's try the second derivative, f double prime of x. Well, f double prime of x, I'm going to use the product rule, so I differentiate the first term. That gives me minus 26 times by sine of x squared. I leave the first term alone, which is negative 26x. Then I multiply by the derivative sine of x squared. That'll give me cosine of x squared times by 2x. Let's just write this out one more time. So minus 26 times by the sine of x squared minus 52x squared times by this cosine of x squared. Okay, well, absolute value of f double prime of x, we need to find something that this is less than or equal to. And this is equal to just minus 26 times the sine of x squared minus 52 times by x squared times this cosine of x to the x squared. And hey, look, that's less than or equal to if I take the absolute value of each term. So minus 26 times by sine of x squared plus absolute value minus 52 times by x squared times by cosine of x squared. And hey, I know that that first term, sine of x squared, is less than or equal to 1 in absolute value, so why don't I just put 26? This next term, I know that x squared, the largest it can be is 1 on the interval from 0 to 1. And likewise for cosine, the largest it can be is 1. So why don't I do 52? So I think I'm going to have 78 as one possible upper bound. Now, this isn't necessarily the only upper bound, but I'm going to use that value of k here, and I'm going to get 78 over 24 times by 4 squared. And now I just need to type that into my calculator. That will be 0.2 approximately. So I know that this answer is good to within 0.2 of the actual answer. Okay, and technically this is 0.203 if we want to be really precise, depending on how many significant digits we want. Okay, thank you very much. That was just a brief introduction to how to use the midpoint rule along with this error bound.